Hello and welcome everyone to a brand new episode of the IEEE Talk podcast. I am Yasmina Kenzari, your host, and it's a pleasure to have you here. Today we're introducing a fascinating new series where we explore the master's program at the Institute of Electrical and Electronic Engineering, also known as INELEC. We will explore the four majors: computer engineering, control engineering, telecommunications, and power engineering, in order to help you navigating your academic and career choices. And what better way to start than with computer engineering, a fascinating field driving innovation from microprocessors to artificial intelligence. To explore this field, we have a very special guest, not only for you, but for me as well. He was my teacher, my lab instructor, and most importantly, my supervisor. Not only that, but he was my mentor, guiding me in both technical field and work ethic, making me the person I am today. He is a professor at INELEC, teaching computer architecture and advanced microprocessor interfacing. Please welcome Professor Abdelhakim Khouas.
Thank you for inviting me, and thank you for this introduction.
Yeah. Before we dive into computer engineering, let's get to know you better. Would you please introduce yourself and share your journey and how did your career develop?
Yes, thank you again for the invitation and for the introductions. And also I wish Ramadan Mubarak for all the students here at INELEC and for all the Muslims in the world. Okay, so I did my study here in Algeria. Okay, before the bachelor's, I got the bachelor's in 1999, and then I went to France, where I did class préparatoire for preparing to engineering school, and I did my engineering at Institut Supérieur d'Électronique de Paris in electronics. Then I went to University of Paris 6, which is Sorbonne University today, where I did the equivalent of the master and my PhD in integrated circuit and computer design. After my PhD, I went to Montreal, where I taught at École Polytechnique until 2008, and then I came back here to University of Beaumarchais.
It's truly inspiring to hear your journey into this field. Now let's dive into our discussion with our first segment, the journey into computer engineering. Let's start from the very beginning. Professor Khouas, what made you choose computer engineering? Was it a planned decision or did you stumble upon it by chance?
It's both. For electronic engineering, it was stated. I mean, I planned to do this electronic engineering. For computer, it's coincidence. I got a scholarship to do my PhD in integrated circuits, which is related to computer. And then I started from my PhD working on computer engineering.
That's fascinating. And with the field evolving so fast, how did you develop yourself in order to keep up? Did you face any challenges in your early days, and how did you overcome them?
Chance to did my PhD at the University of Paris 6. So we had all the equipment, and we had access to the information, to the books, to the journals. So it wasn't difficult. I mean, to work on computer engineering. And I started working in 1992, and it was the years where we started really working on computers. I mean, we started using computers, the new computers, the Intel 286, which is the first really computer used by the public, was sold, I think, in 1988, 1989. So I was really in the beginning of the evolutions of the computers. So it wasn't so difficult because we had everything at the university.
Now let's bring it to INELEC. Can you give us an overview of the computer engineering major at INELEC?
Yes, of course. So computer engineering in general, we had two different specialties in computer engineering. So we had more computer engineering, which is about more designing computers. And we have also computer engineering, which is about more using computers and interfacing with computers. Okay, that's why, for example, if you take computer architecture books, you will find the two types of books. Some books are about more designing computers, and some books are more about using computers. Here at INELEC, it's more about using computers. So the courses here at INELEC and the courses of computer is mainly to learn, of course, to learn how the computer is designed, but mainly to learn how to use computer and how to interface with computer.
That's a strong foundation. But beyond coursework, what skills should the student develop in order to succeed in this field?
I think the most important is the logic, more than maths in computers. I know that in other specialties, maths are more important. In computer engineering, the logic is more computer. Then you have the hardware, and then the software. And today, we need what we call the hardware-software design. Okay, so logic, hardware, software, that are the most important concepts that you need to have to be good computer engineering.
A common dilemma for students is choosing between computer engineering and control engineering. I was one of them, by the way. What are the key differences they should consider in order to make their decision?
Computers engineering and control engineering are completely different. For example, in control engineering, we need maths. The most important concept that we use is maths. And in control engineering, we learn how to control systems, different type of systems. Okay, as I said, in control engineering, we need more maths, and we need also what we call controlling systems to understand controlling systems. And in computer is more computer and more programming. So I don't know why, especially this between control and computers, because they are completely different.
It's like for INELEC students, most of the time they are confused in choosing between them.
Yeah, but as I just told you, I don't understand why it's confusing, because it's completely different. Control, you will work mainly on system. Of course, you can use computers to develop control algorithms or to implement control algorithms. But you use computer as all other, engineers use computers. So you will use the computer. You don't need to understand how the computer is designed and how to work with computer at the low level, how to interface computer. So it's really not related to computer, okay? But computer, I will understand if you have to choose between computer engineering and computer science, because they are close, okay? But between control and computer engineering, it's completely, and it depends. What do you want to do? What do you like? If you like maths and you love maths, you do control, okay? If you like computers and you want to understand computers and how to interface with computers, you choose computer. And I always tell the student, try to choose what you want to do, because at the end, when you work in the field that you like, it's always easier, okay, than working in a field that you really.
For me, both fields were interesting, but the thing that made me choose control engineering is because I'm fascinated by robotics. That's why I made this choice.
Yes, and I forgot this. Control is more robotics. Yeah. If you like robotics, go control. Yeah. If you like computers, because you have to understand, computers and robotics are completely different, okay? Because programming robotics you use computer to program robotics, but it's not like programming at a high level or programming. And I think this is the good answer. If you like robotics and you want to work on robotics, you choose control. But if you like computers, you want to understand computers, you go to computer engineering. If you want to work at the high level, to use computers at a high level, you go to computer science.
So guys, the point is choose what you want to pursue. That was so helpful. And speaking of preparation, how does the program prepare students for industry and research opportunities?
Yes, as I said, here at the institute, the program, it prepares more the student to for the computer engineering to use the computer at the low level. Okay, so to program the computer at the low level, or also to interface the computer. Okay. And there are some courses about computer science, like the Java course, like the data structure courses, like the high-level programming courses, which help the student to understand how to use the computers at the whole level. But mainly here, the program at the institute, it prepares the student to really work in the field of programming the computers at the low level. I don't know if I answered the questions, or
prepare students here, the master students, to pursue like industry opportunities or research opportunities.
Of course, there is the lack of the industry collaborations. Okay, so the program here at the institute, it's really good for computer engineering, as I said, for the engineers who want to use computers. But of course, the preparation for the industry, I think there is a little bit lack of the collaborations, and also, let's say, lack of some labs, practical labs for some courses and some. But in general, when I see how our students performs when they went outside, I think that in general the program is good for the industry, and for the research. It's different. I think that we don't have courses or enough courses to prepare the students for the research, and I think this is also because of the program is fixed by the ministry, and you cannot change many things. So when they come, I mean, when the students start to do research, I see that they are not really well prepared. But of course, I think with the time, they improve their way to do the research.
So it's more about how students develop themselves during their master's program.
No, I mean for the industry, I think the program is good. I mean, there are some lacks, but it's good. For the research, the students they have to work by themselves to improve their abilities to do research. Okay, and before, when there was a master, I mean, the old program with magisters, it was in the magister that students learn how to do research. But now with the new program, we move directly from the master to the PhD. So the students, they come to the PhD without really basis in how to conduct the research. But the student have the technical concept. This is the most important to do research or to go to.
With AI, cybersecurity and embedded systems evolving so fast, where do you see the future of computer engineering?
I mean, for me, AI is opportunity. So this will not really affect the computer engineering, because AI systems cannot build for your computer or cannot use for your computers. Of course, it will help you to work with computers. But I don't think that this will really affect computer engineering. It's like when we start working with the internet and with Google, and we ask the same questions, but today we still working in the same way with Google systems. So I think the same thing for AI. AI will help to improve computer engineering, but it's not a threat for computer engineering.
And finally, what is the golden advice you would give to students considering this field, and also for those who are already studying it?
To work hard. I mean, this is the student, they really need to work hard, and they also need to work outside. I mean, outside. As I always say to the students, mainly to learn programming, to learn interfacing circuits, you need really to write programs. We cannot learn just by reading books. It's like driving cars. We cannot learn driving car just by reading the book. So the advice is to work hard, and unfortunately, I see many students, they lose their time doing other things, and they don't put enough effort in studying.
They say all work and no play makes a dull day. So let's switch things up with a quick, fun segment. For the first part of our game, you will have two options, and you have to pick one without thinking. Okay, let's start.
Do I need to pick one or another one that is not
No, you have to pick one.
proposed?
You have to pick one of the proposed ones.
Even if both are not...
Yeah. Artificial intelligence, threat or opportunity?
Opportunity.
Got it. Teaching or research?
Very hard. Research.
Okay, nice. Windows or Linux?
Linux.
Now a tricky one. Z80 or ARM?
Z80.
Okay. The last one. Assembly language or high-level programming?
Assembly language.
Now the second part of our game. Quick question, quick answer. My first question is, if you would upgrade the Z80 with one modern feature, what would it be?
Wireless communication.
Okay. Now about students. The best quality a student can have.
The best
Quality
student can
have. Yeah.
Working hard.
Okay. That's a great quality, actually. My next question is, what's the best part of being a professor?
Teaching.
Okay. Now, an interesting question. One word to describe your teaching style.
One word.
Yeah.
This is difficult. Okay. Explaining how, the why before explaining how it works.
Can you explain more?
You said one word, okay?
Yeah, one word.
So always I tell the student to try to understand why we do those, why we learn those concepts.
Before understanding how to use them, yeah.
Because the how we forget, but the most important is
the why.
Yeah.
Okay.
So I start always when I teach is to explain the student why we need those concepts.
That's so interesting, actually. So now, supervising licensed students or master students?
You have to choose?
Yeah, you have to.
Master students.
Okay. Can I ask why?
Because you can do many things with master students.
Yeah, I mean more advanced things.
Yeah, I mean we can license it just. In license, we teach the student mainly how to conduct project and how to work with project. Because it's short time
and it's their first time, so
you
cannot work with really advanced topics with them.
License is more, the project is more teaching the student. It's not really a project that the student will do and can do something. And of course, if you ask me PhD or master, I will tell you PhD student.
Yeah, okay. So you will pick always the advanced.
No, because we can do more works, great works, and we can work together more.
Yeah.
For me, a licensed student is like a course. It's similar to project course. So.
Professor Khouas, that was truly enjoyable. Thank you for this inspiring discussion. Do you have any final message you want to share with your students?
Okay. So thank you for these invitations, and for the students, I repeat the same thing. So try to work hard. Okay, this is the most important, and try to really to optimize your time. Thank you.
It's been truly an honor having you here, Professor Khouas Abdelhakim. Your insights made this episode truly valuable. Personally, I am so grateful to reconnect with you, not just as a professor, but as my mentor who shaped my journey. To our audience, I hope that you enjoyed this episode and it was helpful for you to learn about computer engineering. If you did, don't forget to subscribe, leave a comment, and share it with your friends. This is just the beginning of our exciting series to explore the master's program at INELEC, so stay tuned for more exciting and fascinating discussions. Until that time, keep learning, stay creative, and see you in the next episode. Have